Okay, welcome to the next video for method 17D, results with differentiation. This is the first of a two-part video. I'll do the second video later today and it'll be ready for you before your next lesson on Monday. So just a quick recap of what you should have done in 17C, or you should have found in 17C rather. One thing you might have noticed when you were working through the chapter was if you've got something like x cubed, then your the derivative of that is 3x squared. If you had x squared, the derivative of that might be or would be 2x, and if you've got the derivative, if you've got the function x, then your derivative would be just 1. You might also have done something like 2x cubed and found that the derivative was 6x squared. You might have done, let's say, 4x squared and found that the derivative was 8x. And you might have found, if you did 7x, that the derivative was 7. So if you haven't done this in previous years, you may have found the pattern that if I've got a polynomial, something raised to an integer power, then the pattern that emerges from this is something similar to that, which is that the derivative of a function for a polynomial can be found by multiplying the function itself by whatever that power is, and then subtracting 1 from that power. So if I've got x to the power of 4 as my function, the derivative would be 4 times that, and instead of having 4, it would be 4 take away 1, which is 3. So there is a proof to show that this will happen in all cases. I'm not going to do it here, but I'm going to upload soon a supplementary video to go through the proof of why this rule holds for polynomials. I highly encourage you to go look at that when it's up. So for today's lesson, there's a couple of rules when we're dealing with polynomials that are quite useful to remember. And the first one is that if I've got a function which is a constant, then it doesn't matter what that constant is, the derivative is always going to be 0. So for example, if I have my function of x equals 7, then my derivative is going to be 0. Doesn't matter if it's 8, 9, 327, pi. If that's the function, the derivative is 0. If I've got a function that is just a multiple of another function, another polynomial, so let's say that we've got f of x equal to 2 times whatever g of x is, then actually that's my example, I should put that there. So if it's being multiplied by a constant, then my derivative is just going to be the derivative multiplied by that constant. So if, for example, then my function is 2 times g of x, then the derivative is going to be 2 times the derivative of g of x. If my function of x is the sum of 2 other functions, then the derivative is going to be the sum of those derivatives. So in other words, if I've got a function which can be described as g of x plus h of x, then the derivative is going to be the sum of those derivatives. And similarly, if I've got the difference between two, then the derivative is going to be the difference between the derivatives. So instead of plus, it's just going to be subtract. So if I've got a function that's defined as g of x take h of x, then the derivative is going to be derivative of g minus the derivative of h. So these rules are quite useful to know to simplify certain functions that you're trying to find the derivative of. As you do more practice, you'll find that these come quite naturally, but in these early stages, it's good to be aware that those are some useful rules. So examples. I've just left the rule up here for polynomials just so I can refer to it in the examples. So if I've got the function f of x equals x to the power of 5 take 2x cubed plus 2, then they want me to differentiate that. So using this rule up here, f of x equals x to the power of 5 take 2x cubed plus 2. My derivative, so the rule is I take the power and I multiply it by that term, and instead of having 5 I subtract 1, so it's 4. I take that 2x cubed, multiply it by the 3 because that's the power, then I drop the power. Now the rule for constants is that any constant, the derivative is 0, so I'm not even going to write plus 0. So, second example. I've got f of x equal to 3x cubed take 6x squared plus 1. They want me to find the derivative specifically at 1. So, in this example, we were finding an equation or an expression that describes the derivative, and then we could substitute values into that to find out the derivative at specific points. So the value of the derivative, that actually tells us the gradient of the tangent. That's obviously going to change as you progress through the function. So at that point, the value is going to be different to, say, at the derivative for f of 2. So first step is to find the derivative using the same rules. Multiply the power by the coefficient, so 3 times 3 is 9, then drop the power, 2 times 6 is 12, drop the power, so it's 1, so I don't need to put it, and plus 1 is a constant. Now I just substitute 1 into that derivative formula. 9 times 1 squared is 1, take away 12 times 1, which is 12, that gives me negative 3. Okay, so that is the video for today, but before you leave, I'm just going to scroll down to the bottom. Why don't you take a look at that and tell your teacher why that's funny. Thank you.